Hello and good day, doctor. My name is Amizhdhan BALAKRISHNAN and my matrix number is 231363008, and today I'll be presenting about my lab 5, which is Z transform. So you can see here, this is the exercise 5.1 and 5.2, but today I will be presenting about 5.1a and 5.2a. So as you can see here, this is the code. So I'll straight away bring you to the MATLAB software. So as you can see, this is the code. So hi, I'll now walk you through the part A of our MATLAB code, which involves the symbolic Z transform, inverse Z transform, and pole zero analysis. Okay, so as you can see here, for the first two line here we define the transfer function of a system in the Z domain. N is the numerator of the transfer function x, z, representing the coefficient of power of z and in descending order. D is the denominator representing the system's pole roots of the denominator polynomial. So as you can see, for this line we declare z as a symbolic variable which allows us to perform algebraic operations like z transforms and simplification in symbolic math. For this line here, for this code line here, we construct the transfer function as a symbolic rational function, a ratio of polynomials. Z converts the n vector into a symbolic numerator polynomial in terms of z, sum of the denominator using d. And for this line here, this computes the inverse Z transform of x, giving us the time domain sequence corresponding to our Z domain function. So for this one here, displays a heading to separate this section in the output. For this one here, displays the symbolic expression of in a more readable pretty format, and this one also same goes like that. And for this one, Z plane plots the pole zero diagram of the system. Zero root of the numerator are shown as circle, poles roots of the denominator are shown as crosses. This plot is essential for analysis system stability and frequency response. The title makes the plot easy to identify during presentation. So I'll run the code for you now. So this is the figure that I'll be getting. As you can see here, this is the pole and plots and everything. Okay. So summary for this code is, we define a transfer function in the Z domain, found its inverse Z transform using symbolic maths, displayed the result in a readable format, visualize the poles and zeros using Z plane. Okay, for the 5.2a, this is the code. Now let's look at another MATLAB code snippet that focus on analyzing the poles and zeros of the discrete time system. So for this one here, basically this code here, this line here, we define the numerator and denominator of the system's transfer function in the Z domain. Num represent the coefficient of the numerator polynomial. This determines the system zero. Then represents the coefficient of the denominator polynomial. This determines the system's pole. Both are written in descending power of Z. So for this this one here, roots number computes that zero of the system that is a value of Z that makes the numerator zero. Roots and D computes the poles of the system values that makes the denominator zero. The results are stored in a variable 0 and a pole A. So for this Z plane plot Z plane num denominator plots the poles and 0 on the Z plane. 0 are shown as circles as 0. Poles are shown as crosses x. This plot is useful to analyze the stability and frequency behavior of the system. The title helps us identify identify the plot in case we generate multiple figures. So for this one, the last line here, we use display to clearly print the numerical values of the zeros and pole in the command window. This gives us exact positions of zeros and poles, which help us in further analysis like checking if poles lie inside the unit circle for stability. So for the so if I run the code, this is the figure that I'll be getting. As you can see, the plots and zeros here. So for the summary of this coding, we define a transfer function by specifying numerator and denominator coefficient, calculated zero and poles using the roots function, plotted the z-plane to visualize the system's behavior, displayed numerical value for the interpretation. And that's all from me. Thank you, madam.